Okay, in this video we're going to have a look at how we can determine the nature of roots of a quadratic equation. So the thing that we're looking at is what we call a determinant, which in the quadratic equation is the bit under the square root sign, which is b squared minus 4ac. Now, depending on how this calculation works out, will tell us the type of roots that an equation has. So if b squared minus 4ac is greater than 0, then we have two distinct real roots. Now what that means is that as your quadratic equation comes down, as it gets lower and lower and lower, it will cross the x-axis in two places. Or if you had a negative, as it comes up and up and up and then back down again, it will cross in two places. If we had b squared minus 4ac equals 0, that means that instead of having two separate, distinct real roots, we actually have two roots that are exactly the same. So what we tend to say is we call that equal roots. Now what we should technically say is there are two equal real roots. So there's still real roots, there's still two of them, but they're the same. Then we have b squared minus, that should be a 4 there, sorry, 4ac is less than 0. And if that happens, then we end up having no real roots at all. So what happens is that the quadratic curve will not cross the x-axis at all. And then the final one, which is treated slightly separately because it's mainly used for a different type of a question than what I'm looking at in this video, is if it's greater than or equal to 0. So greater than 0 means that there are two distinct real roots. The equal to 0 means that there are two equal real roots. So the only thing we can determine from this is that there are real roots. And that's normally used in another type of question. So what I'm going to do is I'm going to look at how we take a quadratic and determine the roots. So if I took the quadratic expression 2x squared plus 5x minus 6, and I'm going to look at the value of a is the coefficient of x squared, so in this case is 2. The value of b is the coefficient of x, which is positive 5 or 5, and the value of c is the constant at the end, which is minus 6. So if I look at b squared minus 4ac, and I make my substitution, so b is 5, so 5 squared minus 4 lots of a, which is 2, lots of c, which is minus 6. This gives me 25. Take away 4 times 2 times minus 6 will give me minus 48. So take away minus 48 is the same as adding 48. So this will give us 73. So we now have the b squared minus 4ac. We look at what condition it satisfies. Well, 73 is greater than 0. Therefore, we can say that there are two distinct real roots. Okay, if I take x squared minus 3x plus 4, then in this case a would be the coefficient of x squared, which is 1, b would be the coefficient of x, which is minus 3, and c is the constant at the end, which is positive 4. So if I look at b squared minus 4ac, that is going to give me minus 3 squared minus 4 lots of a, which is 4 lots of 1, multiplied by c, which is 4. This gives me minus 3 squared is positive 9. Take away 4 times 1 times 4 is 16. That gives me minus 7. So in this case, b squared minus 4ac is minus 7, which is less than 0. Therefore, there are no real roots. Okay, if we take one more, if we had the quadratic expression 4x squared plus 4x plus 1, okay, in this case a is 4, b is going to be the 4 as well, and c is going to be the constant at the end, 1. So b squared minus 4ac equals, so we have b is 4, so 4 squared minus 4 lots of a, which is 4, lots of c, which is 1. So that gives us 16. Take away 4 times 4 is 16, times 1 is 16. So we get 0. So we can say that b squared minus 4ac equals 0. Therefore, so if they're equal to 0, we have equal roots. And that is how we determine the nature of the roots of a quadratic.